Hello students, welcome you all to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now and press the bell icon to get the notification of the upcoming videos. Students, I promise you to complete your syllabus and would like to solve all your queries which you may kindly drop in the comment box. So dear students, as per my promise, I have completed your syllabus. Now we continue with higher Olympiad and IIT level from IIT Foundations. In my last sessions, we have discussed about relation and functions. Today, we continue with limit. What is limit? Limits describe the behavior of a function's fx, the behavior of a function's fx as its variable x approaches a particular number. Suppose x approaches a particular number a. To illustrate this concept by saying that we will happen to continue, suppose fx is equal to x square plus x minus 2 upon x minus 1 and x approaches, here the limit x approaches 1. Although fx is not defined at x equal to 1, when x equal to 1 the functions cannot be defined. The functions, because in the denominator we will get 0 which the functions cannot be defined. We can get a feel for the situations by evaluating fx using the value x that closer to 1 both from left and right sides. The following, look at here, this x is approaches to 1, but when x is equal to 1 fx cannot be defined. Then x can be approaches from left to 1, then x approaches from right to 1. This is from towards 1 from right and this is from left towards 1, x approaches. Let us discuss about the table. Look at here. Here fx is equal to x square plus x minus 2 upon x minus 1 when x approaches 1. We suppose this is x and this is fx. Then here, look at here. When x equal to 0.8, then the fx is equal to 2.8. When x is equal to 0.9, as we say that x approaches to 1 means x is closer to 1 from left side, LHL, left hand limit. Then this is when x is equal to 0.9, then the fx is equal to 2.9. Then when x is equal to 0.95, because I have already told you x approaches to 1 means x is closer to towards 1. Then if you put x is equal to 0.99, then you get fx is equal to 2.99. Then when x equal to 1, then fx cannot be defined. Here fx cannot be defined. Then when x is equal to, then fx cannot be defined. When x is equal to 1 point, I have already told you x approaches to 1 means x is closer to 1. This is left hand limit, this is right hand. From right hand sides, take x equal to 1.001. Then we get fx is equal to 3.001. Then when you put x is equal to 1.01, then you get fx is equal to 3.01. In the same way, when you put x equal to 1.05, then the fx is equal to 0.35. In this case, you show the function's value in the table suggests that when x approaches to 1, then the fx approaches to, when x approaches to 1, then the fx approaches to 3. Then x is closer and closer to 1, then you get fx is closer and closer to 3. This behavior may be described by saying the limits of fx as x approaches to 1 is equal to 3. Then we can write this as, keep it here. Now let us think, how can we write? Then here we will write when x is approaches to 1, fx is equal to 3, where fx is equal to, fx is the functions which is x square plus x minus 1 upon x minus 1. In this case, when x approaches to 1, the limit x approaches to 1, then this is fx is equal to 3. Okay. Then now let us discuss about the important of limit. Fx is get closer to the limit L, then x is closer to C. This means then when the limit of fx, when x is closer to C, x approaches to C, then we get this limit of fx is equal to L. Then definition, let us note down, students, the important points. Please note down. Definition of limit. Definition of limit says that let a function f be defined at every point in the neighborhood A, then an open interval about A except possible at A if as x approaches closer to A but not equal to A, then the value of the functions approaches to the real number L. This means fx is the limit of fx when x approaches to A is equal to L. Then note that fx approaches to L means the absolute difference between fx and L, that imply fx minus L can be made as small as possible. Can be made as small as possible. Made as small as possible. Okay. This is the definition of limit. Now let us discuss what is RHL. What is right hand limit? We said that right hand limit fx as x tends to exists is equal to L. Then if x approaches to A through the value greater than A, the value of fx approaches to a definite unique real number. Means the limit of, when we think about RHL, right hand limit. Right hand limit. What is right hand limit? Right hand limit, we say that right hand limit of x, when right hand limit of fx as x tends to A exists and is equal to L1 as x approaches to the x approaches to A through the values greater than A. When x approaches to A, the value greater than A, the value greater than A, greater than A, then we say that this is RHL, right hand limit. The limit of fx when right hand limit x value is slightly greater than A, means x approaches to A plus, then this is L1, this is RHL, right hand limit. Then what do we mean by left hand limit? Keep it here. Now let us discuss what is left hand limit. The left hand limit here, this is right hand limit, this is left hand limit. Left hand limit means LHL, means LHL, left hand limit. Then we say that when fx, find the value of fx as x tends to A exist is equal to little smaller than, less than, x tends to A less than A. Then we say that limit of x A minus, because the x value is slightly smaller than A, then this is x minus fx is equal to L2. Here this is L1 is RHL and L2 is the LHL. Then we say that determine when we say that the limit is exist. Most general form of the limit, when we get 0 by 0 form, we say that the limit doesn't exist. When we get infinite minus infinite or 1 upon 0 minus 1 upon 0, then also we say that the limit doesn't exist. When we get infinite upon infinite, we also say in this case limit doesn't exist. When we get 1 to the power infinite, in this case we also say limit doesn't exist. Okay. In these cases we say limit doesn't exist. Limit of sum and difference. Now let us discuss limit of some properties of limits. Now let us discuss properties of limit of sum and difference. Limit of sum and difference. Students, I have already told you this is higher level of IIT foundations. Please be attentive while I am teaching you. The limit x tends to a and fx plus or minus gx is equal to, when this is sum and difference, then this is the property one says that, then we say limit x tends to a is equal to fx plus or minus limit x tends to a gx. When this is bracket, then you open the bracket like this. This is limits of sum and difference. Now let us discuss about limit of product and quotient. Limit of product and quotient. We are now discussing about the properties of limit. Now limit x tends to a fx into gx is equal to, when you open the bracket, which is equal to limit of x tends to a, this is fx, into limit of x tends to a, then limit of x tends to a gx. Okay. Then now if there is a constant x, k multiply with this k into fx, x tends to a, this can be written as, the constant k can be taken out, this is equal to x, limit x tends to a. Students, please be attentive while I am discussing about the properties of limit. This, then you can take out the constant, then this can be written as limit x tends to a fx, where k is the constants. In case of divisions, limit of quotient, limit the, now keep it here, now let us discuss, keep it here. Now let discussed about the limit of quotient. This is limit of sum and difference, this is limit of product. Now let us discuss about limit of quotient or division. Quotient. Then if this is limit x tends to a fx upon gx, then you open the bracket and you can write limit of x tends to a fx upon limit of x tends to a gx. Okay. Now where limit of x tends to a gx is not equal to 0. If gx is equal to 0, you get 0 in the denominator, which is meaningless. Now let us discuss about the evaluation of algebraic limits. Now let us discuss about the evaluation of algebraic limit. Evaluation. Please students, be attentive. If any doubt persists, please ask me in my comment box. I am ever ready to clear your all doubts. Evaluation of algebraic limits. Evaluation of algebraic limits. Here let the fx is be an algebraic functions. Let fx be an algebraic function, be an algebraic function, then the polynomial or the rational number a be any real number, then limit x tends to a, fx is known as an algebraic limit. Then this is known as an algebraic limit. When fx is an algebraic function of polynomial or rational number a be any real number, then we say that this is known as an algebraic limit. Known as an algebraic limit. When I will discuss examples, you will get better idea about the properties. Now, method of direct substitutions. What do we mean by method of direct substitution? Method of direct substitution. What is method of direct substitution said? When you say limit x tends to a, fx can be evaluated by the method of direct substitutions, means fx exists finitely when x is equal to 1. Then if fx exists only for x is equal to 1. When you put the value of x is equal to 1, if fx exists, then can we use the method of direct substitutions. Now let us discuss an examples. Here the example says that limit x tends to 1, the fx is equal to x square plus 2x plus 3 upon x square plus x plus 1. Now let us put the value of x is equal to 1. When you put the x is equal to 1, you get 1 plus 2 plus 3 upon 1 plus 1 plus 1. In this case, this is 6 upon 3, which is equal to 2. In this case, direct substitution method is applicable because fx can exist when x is equal to a. Now let us discuss about the method of factorizations. Now let us discuss about the method of factorizations. The method of factorization. Method of factorizations. What do you mean by method of factorizations, students? Then when you say that when the algebraic expressions we get 0 by 0 form or infinite by infinite form, in this case we say limit doesn't exist. In this case we say, then we find the method of factorizations. Suppose limit of x tends to a, fx upon gx, and such that the substitution when you put x equal to a by substitution method, then you get either this is 0 by 0 form or infinite by infinite form when you put the value of x equal to 1. In this case, we use the factorizations method. What do you mean by factor theorem says? When limit x tends to a, fx upon gx is equal to, when you put and x tends to a but x is not equal to a. When you put x equal to a, in this case you get 0 by 0 form. Then we say that limit of x tends to a, x minus a f dash x upon x minus a into g dash x. Then x minus a cancel. You get limit x tends to a, fx upon gx is equal to f dash x upon g dash x. This is when f dash a and g dash a are non-zero. When you get g dash a or f dash x or f dash a and g dash a. When you get f dash a and g dash a are 0, then you get 0 by 0 form. This cannot exist. Now let us discuss method of rationalizations. What do you mean by method of rationalizations? Students, please, if any doubt persists, if you cannot understand what I am saying, please ask me. What is method of rationalizations? Rationalization. Rationalizations is the method when the rationalization method used, we have radical sign to expressions like 1 upon 2, 1 upon 3. There exists a negative signs between two terms of an algebraic expressions. After rationalizations, the terms are factorized, which on cancellations gives a required preferred value. Now let us discuss about the evaluations of limit using standard rules. Evaluations. Now let us discuss evaluation of limits. Students, now in this IIT Foundations class, I teach you from IIT Foundations book. In my next sessions from April, I will teach you class 11. In this class you will details discussed about what is limit, what is everything, what is relation and functions. Here limit x tends to x to the power n minus a to the power n upon x minus a. Then we say that limit x tends to a is by the method of evaluations of limits. Then this is x of n minus 1 plus x of n minus 2 into a plus x of n minus 3 into a square plus in the same way plus a to the power n minus 1. This is the method of evaluations. Then this is says that limit of x tends to a, x to the power n minus a to the power n upon x minus a is equal to a to the power n minus 1 plus a to the power n minus 1 plus a to the power n minus 1. In the same way we get this is plus a to the power minus 1. Then when we put the value x tends to a, then we get this. Put in place of x we put a. This is equal to n into a to the power n minus 1. Then we say that limit of x tends to a, x to the power n minus a to the power n upon x minus a is equal to n into a n minus 1. This is the method of evaluations. Okay, now students, please discuss about some examples. I have already told you when we discuss those examples we can get better idea about the theory. The example 1 says that let find the k so that find the value of k so that find the question asks that find k so that limit of x tends to 2 fx may exist which is equal to may exist when f of x is equal to x square plus 1 when x is less than equal to 2, and this is x plus k when x is greater than 2. This is the conditions given here. Now limit x, left hand limit when x tends to 2 minus, then fx is equal to when x tends to 2 minus means x is less than equal to 1 equal to 2, then fx is equal to limit of x tends to 2 minus, we get limit of this is fx is equal to x square plus 2 x square plus 1 which is equal to 2 square plus 1 which is equal to 5. Then when limit of x tends to 2 plus means x is greater than 2, then fx is equal to exist is equal to, then here limit x tends to 2 plus, in place of fx we can write this is x plus k which is equal to 2 plus k. Then as we say that the limit exists, this means as limit exists, this means LHL is equal to RHL. Left hand limit is equal to right hand limit, which shows that here 2 plus k is equal to 5. Left hand limit, this is left hand limit, this is right hand limit. As we say that the limit exists, this means LHL is equal to RHL. This means limit x tends to 2 minus fx is equal to limit x tends to 2 plus fx, which shows that 2 plus k is equal to 5, then k equal to 5 minus 2 equal to 3. Here we can find out the value of k. Now let us discuss example 2. Please students, do your worksheets and ask me your doubt. I am ever ready to clear all your doubts. Here example 2 says that limit of x tends to 2 when what is fx? X to the power 101 plus 3. Then here we get when x tends to 2, in place of x we can put 2 to the power 101 plus 3. This is that when limit x tends to 2, fx is equal to 2 to the power 101 plus 3. Then since fx is equal to a, fx is since when x tends to 2, fx is equal to f of a for all a belongs to R wherever fx is a real polynomial. Then now let us discuss another examples. Limit x tends to 2. What is fx? 2x square plus 3x plus 1 upon x plus 2. Then this is limit x tends to 2, x tends to, here x tends to 2, 2 into 2 square plus 3 into 2, in place of x we can put 2, this is 2 plus 2, then this is equal to, which is equal to 2 8 plus 6 plus 1 upon 4, this is 15 upon 4. This is the answer of the questions. Students, in the same way we can solve more and more examples in my next sessions. Today this much. Thank you students.